Hello, this is Susan Poss. We are working now in section 5.2 on exponents and scientific notation. And I made a little list here at the top of the screen. These are the rules that we've already worked on in section 5.1. So if you're out of order with your video watching, you may want to go back and take a look at section 5.1 just to be certain that you understand all the rules. Okay, so we've done the product rule, quotient rule, zero exponent rule, and the negative exponent rule. So now we're going to derive a new rule called the power rule. And it's going to have a couple of subcategories, I guess we can call it. We're going to derive the power rule first, and then we're going to look at a couple of versions of that power rule. So you're going to use the power rule. The way you're going to recognize it is when you see some base written inside the parentheses, it will be raised to some exponent, and all of that will be inside the parentheses. And then outside the parentheses, there will be another exponent. So I always tell students to watch for an exponent on the inside and then a parentheses and an exponent on the outside. That's when you're going to use the power rule. All right, so I'm not going to give you the rule just yet. We're going to actually derive it from some things that we already know. So here's the first example. It's inside the base x raised to the exponent 5, and then we're raising that to an exponent 2. So what does that mean? It means that this base, x to the 5th, is used as a multiplier twice, 2 times. And based on our product rule that we talked about earlier, the way we could do that is to add those two exponents of those two like bases and end up with x to the 10th. Here's another example, a base y squared, and this base y squared is being used as a multiplier 4 times. So if we used our product rule, we would be combining all of these 2's because the base y is a like base. And I hope by now that you're seeing what the shortcut is going to be. So here's a base k to the 3rd, and it's being used as a multiplier twice. Whoops, I said twice and wrote 2. And so that would be base k, and we would use our product rule and add those exponents and come up with base k raised to the power 6. All right, so what is the shortcut? What is the rule? Well, here's the rule. After looking at those examples, we can see that what we could have done was just to go in here and multiply this 5 times 2 to get to the 10. Multiply the 2 times 4 to get to the 8. Keeping the base k, multiply the 3 times 2 to get to the 6, and we wouldn't have to expand all of that. So that's what the power rule says. It says when you're raising a base inside parentheses to a power outside the parentheses, you're going to multiply the exponents together. All right, so here are a couple of, let me leave that where you can see it for a minute. Here are a couple of examples. So x to the 4th raised to the power 3 becomes x to the 4 times 3, or x to the 12th. This one, z to the 3rd raised to the negative 7 becomes z to the 3 times negative 7, which gives me a negative exponent. And remember from last time, you always want to try to write these answers so that they have a positive exponent. So that's using our negative exponent rule. We toss that z to the 21st down into the denominator, and notice that the sign switched from negative to positive as we made that location difference. All right, here's one, base 2 base 2 to the 3rd power raised outside the parentheses to the negative 2nd power. So this becomes 3 times negative 2, which is negative 6. And of course, that's 1 over 2 to the 6th. And when it's a base that is a constant, if it's not some outrageously large number, you want to go ahead and multiply that out. So let me think what that is. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 60, times 2 is 64. Okay, and then this last one, let me go ahead and scroll up. This last one, you would have a base x. You're going to take the exponent on the inside of the parentheses, multiply it by the exponent on the outside of the parentheses. Of course, that brings us to x to the 39th power. All right, so that's a good place to stop for this first video.